Hello everybody, welcome to my first video. Today I'll be covering integration by parts. A very basic integration technique, but it's one a lot of people can struggle with, especially at the start. So we're going to be covering 4 different kinds of integrals today, ranging from very easy to, a bit more challenging. But I'm sure by the end of the video, you'll find it all pretty easy. So the first thing you need to know, and it's what a lot of people struggle with, is the rule LIAT, or however you want to pronounce it. But basically this rule helps you find out what you're going to put as U, what you're going to put as DV, because especially for me that was I didn't know what to do at the start. I was like, what are we going to do? So this rule basically says L stands for logs, natural logs, any kinds of logs. And then I, we have inverse trig. And that's the likes of your arctan, arcsine, etc. We have A for algebraic. So 2x, x squared. You know the types. T for trig. I'm sure we all know them. Sine, cosine, cos. All the likes. And exponentials. So we have e to the x, e to the whatever. You know them all. But by knowing that rule, we'll be able to easily pick out what part of the integral is U and what part of the integral is dV, which is most of the work, 90% of the time. So let's start with a very basic integral. And when you look at this, you don't know where to start if you've never done integration by parts. And there's a simple formula. There's other ways to do integration by parts. There's a DI method, but today we'll just do the normal formula. And the formula states that the formula states that U times dV gives you U times V minus the integral of V times du. And that might just seem like a load of gibberish if you're just starting off with this. So what you want to do, step 1, is lay out on the side U du V dV. Now, as we remember from the LIAT rule, we have a algebraic and we have an exponential. So which one is higher on the list? We see that it's algebraic. So x is going to be our U. And now we need a dV. And we only have e to the x left, so let's put that in there. Now, to get to du, you simply differentiate. That's 1. Make sure you don't forget the dx. I've seen so many people do it. Speaking of. And to get v, we integrate. E to the x integrated is simply e to the x. And here we have all we need to know for integration by parts. It's really that easy. So we take u, which is x, and v, e to the x, minus the integral of e to the x dx. And now you should be seeing how nice this looks. So just multiply it out. And as we know, the integral of e to the x is e to the x. Very simple. Do not forget the plus c. So easy. And it's just such a bad thing to forget. And that's a perfectly valid answer, but if you want to clean it up, we can just say that. And here we go. So that's a very easy integral. And it's a good way to get into integration by parts because you see the LIAT rule, you see how the formula works, and yeah, we can start getting into more complex integrals. I still wouldn't say they're hard yet, but you know, it's a nice starting point. Okay, what do we see here? We see algebraic and a trig. So what do we know? Algebraic is higher than trig. So what's our u? That should be our first thought. What is our u? X. Oh, my bad. Then we need our du, 1, don't forget the dx. And we simply have cos x remaining. And what's cos x integrated? You know, you might go off and do it yourself, or you can just think, you know, what will give me cos x if I differentiate it? And that's obviously sin x. Sorry, don't forget your dx. Okay, now let's plug it into the formula. So we have u times v minus the integral of v du. So let's sub it in. X times sin x minus the integral of sin x dx. Okay? And as we just figured out, the integral of sin x will just be minus cos x. As again, you got to think, what's going to give me that if I differentiate it? So we have x sin x. Sorry, I forgot the x there. Minus cos x, so that just gives us plus cos x. And don't forget your plus c, and simple as that, we have our answer. Okay, and we have two integrals perfectly solved, perfectly correct. And that should have been no bother to you. Okay. Let's try something a bit more complicated. Okay. Here we go. Let's do the integral of x squared sin x dx. Straight away, what are we doing? U du v dv. And we're thinking, what is it? We have an algebraic, we have a trig, just like we just done. So, here we go. X squared and sin x. Okay, dx. Simple power rule here, 2x. Okay, now, what is sin x integrated? You know, as we've seen before, you can go down the route of actually integrating it, but I think for simple ones like these, it's the best just to think about it in the head, think about the circle, the what do I have to differentiate to get to this? And to get to sin x, we have to differentiate minus cos x. So that'll be our v. Okay, here we go. Put it into the formula, u times v. Drill this formula into your head and you won't forget it. Just like I seem to be. Du. Do not forget this formula. It's really easy. Yeah. So we have x squared times minus cos x minus the integral of minus cos x times 2x dx. Wow, I am always forgetting the dx. Okay, so let's rewrite it. Let's make this easier for ourselves. So we have minus x squared cos x. Okay, and I'm thinking here, we just take out the 2. Well, when we multiply these together, we'll get a minus 2x cos x. So let's just take out the minus 2. And that'll become plus, because of minus minus plus. 2 integral of x cos x dx. X cos x dx. And look at that. We have that here. So this is one of those integrals where you kind of have to do it by parts twice. And, you know, getting to here is the hardest part, because we just did the integral of x cos x. So we know that answer. But if you're in a test and you got this, you would know, you know, I have to integrate this by parts again, do my du, v, dv, you know, and you'd be able to solve that. So, but we know already that the integral of x cos x is simply x sine x plus cos x. There we go. So what do we do? Oh, sorry guys. So since there's a 2 outside it, we'll just say 2. We'll say 2x sine x plus cos x. And we'll just throw the plus c on the outside. So then we'll put it all back in. We get minus x squared cos x plus 2x sine x plus 2 cos x plus c. And that's a perfectly valid answer. Like I said, you know, if you are asked to simplify, then you can simply just, let me think, you can simply just take out the cos x, and that gives you a nicer looking answer. Minus x squared plus 2 plus 2x sine x plus c. And there we go, there's a simpler way to write that. Okay, and then we have 3 integrals done. We have the basic one, we have one involving trig, and then we have one kind of double by parts. Let's do one more for this video. Okay? We'll do one. Whew. This is a pretty big one. So this is another one that will likely involve double by parts, which, you know, shouldn't be a problem for us now because we just learned how to do it. Okay, so as we do, x squared is algebraic, e to the x is exponential, u, du, v, dv. Okay, x squared, we're just running through the motions at this stage. It should feel like clockwork doing this. And e to the x integrated, simply e to the x. Okay, let's plug into our formula. U times v minus the integral of v du. So what's our u? Our u is x squared times e to the x minus the integral of e to the x times 2x dx. Okay, so we see here, you know, let's just simplify it first and then worry about that later. X squared e to the x minus, let's just take the 2 out straight away. Minus 2 integral of x e to the x dx. Okay, and sure, this was problem 1, wasn't it? Yep. So we know this answer, but let's just, you know, will we run through it? Why not? We'll just run through it. So we know u is our x, dv is our e to the x, du is our 1 dx, and v is our e to the x. Okay. Another little formula, let's just plug it straight in. We know it by now. U times v minus integral of v dx. Perfect. E times e to the x. The integral of e to the x is e to the x. Come on, we're getting basic here. And since there's we do have a 2 outside it. Minus 2. Let's just, yeah. So is that our answer from before? Of course it is. Yeah. There we go. So now that we have that, let's just simply put it back in. Here we have x squared e to the x minus e to the x 2x minus 2. And what are we forgetting? I hope someone's thinking it. We are forgetting the plus c. Okay? And sorry, I forgot to put down that we're supposed to multiply the 2 in here. And that's why we got what we did. Okay, like I said before, usually 90% of the time this will be a perfectly acceptable answer. But on the odd time they might say simplify, how easy is this? Just take out the e to the x and we have a little quadratic in the middle. Plus c. Do not forget the plus c. I will say this till I die. There we go. And that's the 4 integrals we set out to solve. Okay. So, that's the end of the video. I hope you were able to bear with me with my first video. Yeah, if you have any questions, any integrals you'd like me to solve, any topics you'd like me to move on to, I'd be more than happy to. So just drop a comment if you want something. I cover anything maths, physics, kind of late leaving cert into college level. So just drop me a comment, let me know, and I hope you enjoyed. Thanks very much for watching.